Now that gets a little interesting. We don't want the lymph to just be in those vessels and not being pushed to these big veins, okay? Because if it doesn't circulate, well, you're going to get the buildup of fluid in those tissues, which is edema, okay? One of the biggest things you can do to push the lymph fluid, skeletal muscles. All right? How long should you technically sit? What's the longest you should sit without moving? A good amount is 20 minutes. Okay? But you should move every hour. Okay? Have y'all heard of all this stuff about how they're saying the sitting is now killing us? Okay, this is the reason why. Okay? We're not circulating the fluids of the body, and we're not getting rid of all these wastes that are building up from cells in that fluid. So, skeletal muscle. What's that got to do with anything?
When you're contracting and stuff, forcing stuff back up into the bloodstream through the valves because they're one way. So when you pump your leg, when you move your leg and it contracts and moves, it forces everything back up toward your heart.
Okay. And we do. We have to push all of this fluid against gravity. You know, gravity weighs us down every day, okay? 24/7, 365, 366 if it's a leap year, okay? Respiratory movements. In the pictures for the lymph nodes and the trunks, where was a lot of that located?
Where the lungs are, like the base.
Where this chest cavity is located. Every time we breathe, we are putting pressure on the movement of that fluid. And this is where we find the big veins it wants to empty into. So respiratory movements are important. In some of the larger vessels, we've got some smooth muscles. But the overall goal, keep the lymph moving. Now, when compared to the movement of blood, it's very slow, okay? Lymph is a very slow moving fluid, mainly because we've got to push it through these lymph nodes, all right? And we need it, we want it to be done slowly so that those cells sitting in the lymph nodes, and you know, that it can just be cleaning it, eating the stuff that's in there. Anything that obstructs the movement of the lymph, okay, it causes fluid to build up in those tissues, and we get edema. Now, as we have that lymph flow go through those vessels, make it to a lymph node. Ta-da, 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 ta-da. What is sitting in the lymph node? White blood cells. Macrophages, large white blood cells that like to eat the foreign stuff. T cells. Where did they come from? the thymus gland. Because they got produced, they went to the thymus gland, they got treated with thymosin, developed into the T cell, they make their way to the lymph node, and they sit and they wait. They just wait for something. They're like, oh boy, is today my day?
So the thymus is released.
Once they get mature, they just leave the thymus gland and move to the lymph nodes. Because the T cells are kind of special. Yeah, they're going to be very special.
Just like the opposite of
Yeah, they just kind of, is today my day? What I gotta do? Is that for me? Oh, they just sit and wait. And those little lymph nodes. Lymph nodes are glands that are found along this pathway. They contain those T cells and the macrophages. They want to be ready for something. Now, I want you to look at the structure of the lymph node. One of the things about a lymph node, it has a lot of reticular tissue. All right? Remember those three, the collagen, the elastic, and the reticular? Okay? This one has a whole lot of the reticular. And when reticular works, it forms stuff that's kind of webby. Okay? What can happen in a structure like this if stuff's flowing through it? It can get trapped. So, T cells, macrophages get trapped. The lymph moves in, particles are in it, particles get trapped, and the cells attack it. Isn't that kind of cool? The lymph nodes, we have a lot in the cervical region, axillary region, our supratrochlear. I know it's kind of weird right there, right? But anyway, go with it. All right. Our inguinal lymph nodes in the pelvic cavity, in the abdominal cavity, and in our thoracic cavity. This is where the lymph nodes are concentrated. Everywhere else is going to be the vessels. Okay? So all that fluid makes its way in some fashion to these areas of the lymph nodes. Their job, filter the particles, act with immune surveillance, looking for stuff, okay, that we're going to get with the macrophages and the lymphocytes. The lymph, along with red bone marrow, okay, one of the things that'll happen is we will look at those lymph nodes to help develop lymphocytes. Make those cells proliferate. All right? So if there is a T cell that gets activated in that area of the lymph node, it can also proliferate. Make more of that cell. The thymus is extremely important. Not sure if you guys remember, but in children, babies, up until roughly puberty, huge, okay? Because the job, form as many T cells as it can. Because as we get older, it shrinks and shrinks and shrinks until if you live long enough, it's gone. T cells have been created. The more stuff you get exposed to, the more T cells get specific. And that T cell creates a memory of that. So the thymus is extremely important in giving us those T cells. Roughly until about puberty. And then as we begin to get older, like your age now, it has involuted a little bit, but it's still a good size. My age, it's even smaller, but still pretty good, even though it didn't fight off this last thing I got. Okay? And I'm headed into 3 weeks with it. All right? But the more you get exposed to, the more memory cells will get created. And those memory cells, guess where they go and sit and wait? In a lymph node. Isn't that cool? Now the spleen. Once again, we're looking at an organ, and this one, once again, made up of a lot of reticular tissue. But when we think of the spleen, what do we think about? The blood cells. We think of it as the blood organ, right? Yes, it is, okay? It's where the red blood cells go to die. However, what we find in the spleen, we're going to have two tissue types, the white and the red. Guess what? Red for the red blood cells, white for the white blood cells. So, the job helped to filter the blood. So that tells me we're going to also have some of those cells in the spleen that help with fighting off pathogens. Right, because it's going to have the ability for those cells to be available. As the blood flows through it, it has the ability for them to be available to help fight pathogens that are trying to come through. They're like, not so much as much sitting and waiting, like in the lymph nodes, but they are available and they can be kind of called up for action. Now, when we begin to look at what we need to do for infection, what our body has to do for infection, anything that is going to invade our body and is foreign is a pathogen. So it's like a broad term covering everything. A pathogen, anything that causes a disease, this could be bacteria, viruses, microorganisms, spores, anything. Okay? Now, when we begin to look at our body's defense system, we have 3 levels of defense. Write that down. We have 3 levels of defense. Our defenses are termed either innate or adaptive. Innate. What does that mean? You just have it. What does it mean to be adaptive? We got to get exposed to it, and we got to mount a defense. it becomes very specific. When we look at innate defenses can be species resistance, mechanical barriers, chemical barriers, natural killer cells, inflammation, phagocytosis, fever. Stuff that just happens. Now, species resistance could be based upon the species. My virus that I've had, did my dog get it? Species specific. Mechanical barriers. Skin and mucous membranes. Every hole of your body that is open to the outside has a mucus lining. Think about that. Mechanical barriers. First line of defense. Mechanical, my first line of defense. My skin and my mucous membranes are my first line.
So mucous membrane.
Any hole that's open to the outside environment has mucous membrane. First line. How many lines of defense did I say we had? 3. My first line are the mechanical barriers. If something is a chemical barrier, enzymes, proteins, these are in a body fluid. Heard of any of these? Interferon, defensins, collectins, complement. Heard of any of those? Okay. Enzymes, proteins in the body fluid. So that tells me my cells produce that. Okay. Interferons, helping with phagocytosis. The macrophages, stimulate them. Defensins come from neutrophils, some of the other granulocytes. They're going to deal with some of the microbes. Collectins, bacteria, yeast, and a couple of viruses that we can be exposed to. Complement. Complement is a cascade of reactions. Very complicated. I am not getting you into that. Okay? But what it wants to do, stimulate inflammation. What's inflammation? Swelling. We'll look at it a little more. Attract phagocytes, the white cells that'll eat the stuff, and enhance it. Would you say they're pretty important now? Okay. Natural killer cells. Sounds kind of cool. I do believe if somebody got inventive enough, they could make a movie out of these. Okay, it could be like some alien movie, the natural killer cell. Just saying. A very small population that defend against viruses, And look at this one. And cancer. What they do, they secrete cytolytic, cell splitting, burst the cell, kill it, substances. They're called perforins because basically they make a perforation in the cell that they're attacking, okay? Destroy it. They're kind of cool. Inflammation. Redness, swelling, heat, pain. Should you always try to stop pain? No. Okay? Should you always try to bring down a fever? No. Sometimes you need to let that fever do its job. Okay? Here's what happens. Blood vessels dilate. Capillaries are more permeable. This increases fluid into the tissue spaces. If that occurs, white blood cells can invade. So if something is trying to invade your body, would you say so far this is a good thing to have happen? All right. Tissue fluids, if needed, have clotting factors. So if we have cut our finger, we see it. I know that right now, this process is going to occur because I have passed my first line of defense. I have broken through my skin, and this didn't have a mucous membrane, but it was skin. So I have crossed my first line of defense. Is that correct? So now, I got to have my second line of defense. So, it's going to probably, you're going to probably be, ow, and start sucking on your finger, right? Don't. Okay? Because your mouth has more bacteria in it than a dog's. Okay? Bleeding, stuff from outside trying to go in. Okay? But if I let this take place, look at what's going to happen. Fibroblasts can arrive, phagocytes are active, and I can let healing occur. Now, if I had that, I ain't gonna get into that. Okay, so inflammation. All right, phagocytosis. They're the large white blood cells that can come in and eat the stuff. So the macrophages, these phagocytes, okay, look at this, are also in the blood vessels. Where do the lymph vessels travel close to? Blood vessels. Now, blood vessels are also located, if we look at the capillary beds, what are they close to? The tissues, the cells, the extracellular fluid. They are found in the blood vessels, tissues of spleen, liver, or bone marrow. The most active neutrophils, monocytes. They're usually the first to arrive. A monocyte that leaves the blood vessel, that becomes a macrophage. Chemicals that attract these eating cells, because phago means to eat, okay, to an injury, Chemicals are termed chemotaxis. When you cut your finger, it immediately, the cells themselves release a chemical and say, get here now. And we'll have some of these monocytes that will be present. And they can just get there right now. Some of these monocytes that become the macrophages can be fixed in tissues. In some cases, this can actually be the matrix. Do you guys remember the matrix? Like the jelly type tissue stuff, okay? And also my lymph nodes. Because it's, well, the lymph nodes, based on their structure, trap these cells. Or they can be free. Meaning they can fly around in the extracellular fluid just looking for stuff. They are extremely important. Why?